Blank screen, blinking cursor. That feeling of endless possibilities mixed with total overwhelm. Sound familiar? Well, what if I told you that in the next hour, we're going to transform a simple idea into a fully functional, deployed website that you can show off to the world. No templates, no shortcuts, just pure coding efficiency. Buckle up, because this is going to be intense. Today, we're building TaskFlow, a modern task management app with real-time updates, user authentication, and a sleek interface. Think of it as Trello meets Notion, but we're building it from scratch. This isn't a toy project. This is production-ready code that you could actually use or show in your portfolio. Let me show you what the finished product looks like. Step 1, the 5-minute plan. Here's where most developers waste time. They jump straight into coding. Big mistake. The first 5 minutes of planning will save you 30 minutes of refactoring later. Trust me on this. Let's quickly map out our tech stack, features, and architecture. This isn't about creating the perfect plan. It's about having a roadmap so we don't get lost in the code jungle. Our battle plan. Frontend. React with Vite for lightning-fast development and hot reload. Backend. Node.js with Express. Simple, powerful, and everyone knows it. Database. MongoDB because flexibility beats rigid schemas for MVPs. Styling. Tailwind CSS utility first means we code faster. Deployment. Vercel for frontend. Railway for backend. Both have generous free tiers. Authentication. JWT tokens. Secure and stateless. Stopwatch time check. 5 minutes in 48 coding minutes left. Let's initialize our project. I'm using Vite because Create React App is painfully slow. Time is money, and Vite gives us instant hot reload. Here's the command to spin up our React project with Vite. Notice we're using the React TypeScript template, yes. TypeScript adds a tiny bit of setup time, but it'll save us from runtime errors later. Trust the process. Terminal commands to initialize a React project using Vite with TypeScript template. We install Vite, Fast Development Server, Tailwind CSS, Utility First Styling Framework, Axios, for API calls, React Router DOM, for navigation, Zustand, lightweight state management, and DNDKit libraries, for drag-and-drop functionality. The npm create Vite command scaffolds the project, npm install downloads dependencies, and npm run dev starts the hot reload development server on localhost. Boom! Development server is running. See that? Instant hot reload. While the front end is setting up, let's multitask like pros and get our back end ready. This is where the magic happens. We're not doing things sequentially, we're overlapping our setup to save precious minutes. Open a new terminal tab. We're going parallel. Now let's scaffold our Node.js backend. Express is our framework of choice because it's minimal and gets out of our way. We'll also install the essential packages. Mongoose for MongoDB, JWT for authentication, BCRYPT for password hashing, and cores because our frontend and backend are on different ports. Backend initialization commands for Node.js with Express. We create a backend folder, initialize npm project with npm init y. Install Express, Web Framework, Mongoose, MongoDB Object Modeling, Dotenv, Environment Variables, Cores, Cross-Origin Requests, JSON Token, JWT Authentication, BCRYPTJS, Password Hashing, and development tools like NodeMon, Auto Restart Server, and TypeScript. The folder structure is organized with src containing models, database schemas, routes, API endpoints, controllers, business logic, and middleware authentication checks. Stopwatch time check. 12 minutes in setup complete. Let's code. Let's build our Express server. This is the heart of our backend. It handles all incoming requests, connects to MongoDB, and serves our API endpoints. Notice how clean this is. That's intentional. We're using environment variables for sensitive data like database URLs. The core's middleware allows our React frontend to talk to this backend. And Express.json. lets us parse JSON request bodies. Simple but powerful. Main Express server file that initializes our backend application. We import Express, Web Framework, Mongoose, MongoDB ODM, CORS, 4 cross-origin requests, and .env, environment variables. The app variable is our Express application instance. We set up middleware, CORS, enables Frontend communication, Express.json, parses JSON bodies. The Mongoose.connect line establishes database connection using mongod_URI from environment variables. We create a health check endpoint at /API/health to test if server is running. Finally, app listen starts the server on the specified port, default 5000, making our API accessible. Now for our database schema. This task model defines the structure of our tasks in MongoDB. Each task has a title, description, status for tracking progress, priority level, and timestamps. The user ID field links tasks to specific users crucial for multi-user support. Mongoose makes this super clean with its schema system. And that timestamps option, automatic created at and updated at fields. Less code we have to write. MongoDB task model schema using Mongoose. We define the structure for task documents in our database. The title field is required and trimmed of whitespace. Description is optional with empty string default. Status uses enum to restrict values to do, in progress, or done for task workflow states. Priority similarly restricts to low, medium, or high. The user ID field is a MongoDB object ID that references the user model, creating a relationship between tasks and users, essential for user-specific task lists. The timestamps, true option automatically adds created at and updated at fields to every document, saving us from manual date tracking. Finally, we export the model for use in our API routes. Here's our task controller, the brain of our task operations. We have CRUD operations: create, read, update, delete. The getAllTasks function filters tasks by the logged-in user. Create task builds a new task. Update task finds and modifies existing tasks. Delete task removes them. Notice the try-catch blocks? Essential for handling errors gracefully. And we're always sending back proper HTTP status codes. This is production quality code. Task controller implementing CRUD operations: create, read, update, delete, for task management. Each function handles a specific operation. GetAllTasks retrieves all tasks for the authenticated user, our user.id from JWT, sorted by creation date descending. Create task instantiates a new task with data from request body and saves to database returning 201 status. Update task uses find1 and update to modify existing task matching both _ID and user ID. Security measure ensuring users only update their tasks. With new, true, returning updated document. Delete task removes task with find1 and delete checking ownership. All functions wrapped in try-catch for error handling. Sending appropriate HTTP status codes: 200 success, 201 created, 400 bad request, 404 not found, 500 server error, and JSON responses. The req.user.id comes from authentication middleware that verifies JWT tokens. Stopwatch time check. 28 minutes in backend is alive. Frontend time. Let's build our main taskboard component. This is where React shines. We're using state to manage our tasks, and the useEffect hook fetches tasks when the component mounts. The drag and drop functionality comes from DNDKit, super smooth animations with minimal code. Each task card is draggable, and we update the backend when tasks move between columns. This is real-time task management at its finest. Main taskboard React component managing the Kanban-style taskboard interface. We import useState for managing component state, useEffect for side effects, data fetching, DND context and related DNDKit components for drag and drop functionality, and Axios for API calls. The task state object organizes tasks by status, to do, in progress, done, into separate arrays. Use effect with empty dependency array runs fetch tasks once on mount. Fetch tasks makes authenticated GET request to backend using authorization header with JWT token from local storage. Then calls organize tasks to group tasks by status. Handle drag end fires when user drops a task, extracting active, dragged item, and over drop target from event, making patch requests to update task status in database, then refreshing board. The JSX renders DND context wrapper with collision detection and drag handler, containing a 3-column grid where each column, task column component, displays tasks for its status. This creates the interactive Kanban board experience. Check out this transformation. On the left, we have our raw component code looks complex, right? But on the right, see what it creates. A beautiful interactive task board that responds instantly to user input. This is the power of modern React development. What takes 50 lines of code creates an experience that feels premium. Let's add the styling with Tailwind. This is why I love Tailwind, no context switching between files. Our styles live right in the JSX. The gradient background, rounded corners, shadows, hover effects, all handled by utility classes. And it's responsive out of the box. The grid automatically adjusts on mobile. This would take 100+ lines of custom CSS, but Tailwind does it in one class name string. Task card component demonstrating Tailwind CSS styling power. We define priority colors object mapping priority levels to colored left borders. Blue for low, yellow for medium, red for high. The component returns a div with comprehensive Tailwind classes. BG white for white background, rounded LG for rounded corners, shadow MD for elevation, P4 for padding, MB3 for margin bottom spacing. The dynamic priority colors class adds colored left border based on task priority. Hover effects include shadow XL, larger shadow, and scale 102, slight zoom, with transitional duration 300 creating smooth 300 milliseconds animations. Cursor changes from grab to grabbing for drag interaction. Inside, H3 displays task title with font bold and text gray 800 styling. Description uses text gray 600 and text SM for subtle secondary text. Priority badge uses conditional classes based on priority level. High gets red BG red 100 background with text red 700 text. Medium gets yellow, low gets blue. The PX3 PY1 creates pill shape with rounded full. This demonstrates Tailwind's utility-first approach. No separate CSS files needed. All styling inline with semantic class names. Stopwatch time check. 45 minutes in UI is gorgeous. Time to deploy. This is the moment of truth. We've built something amazing locally, but it's not real until it's on the internet. Versal for the front end because it's literally 3 clicks. Railway for the backend because free tier and automatic SSL. MongoDB Atlas for our database because cloud hosting is essential. Let's make this thing live. First, let's get MongoDB Atlas set up. Create a free cluster, whitelist all IPs for testing, and grab your connection string. Then we'll push to GitHub because Versal and Railway deploy from Git repos. One command to initialize Git, commit our code, and push. Modern deployment is beautiful, no FTP, no server management, just pure automation. Deployment workflow commands using Git, GitHub, Versal, and Railway. First, git init initializes a Git repository in our project folder. Git add stages all files for commit. Git commit m creates initial commit with descriptive message. Then we add GitHub as remote origin with git remote add origin, followed by our repository URL. Git branch m main renames default branch to main. Git push u origin main uploads code to GitHub, setting main as default upstream branch. Comments indicate next steps. In Versal dashboard, connect GitHub repository for automatic front-end deployment. Versal detects vite/react automatically. In Railway, connect same repo and add mongodb_URI environment variable pointing to MongoDB Atlas connection string. Finally, update frontend environment variables with vite_API_URL pointing to deployed railway backend URL so frontend can communicate with production API. This Git-based deployment means every future push auto-deploys. Continuous deployment achieved. And just like that, we're live. Look at this, our app is accessible from anywhere in the world. HTTPS enabled automatically. CDN distribution for fast loading. Environment variables secured. This is production-grade infrastructure that would have taken days to set up just a few years ago. Now, 10 minutes. This is why I love modern web development. Stopwatch final time. 58 minutes. We did it. Deployed and live. Let's talk numbers because this is insane. We built a full-stack application with authentication, real-time updates, drag-and-drop functionality, and responsive design in under an hour. That's a complete CRUD API with 3 endpoints, a React frontend with multiple components, database integration, and production deployment. This isn't a toy. This is portfolio-ready code. Here's what makes this workflow so powerful. We didn't waste time on perfect planning. We had a vision and executed. We used modern tools that do the heavy lifting: Vite for speed, Tailwind for styling, managed services for deployment. We wrote clean, maintainable code that you could actually hand off to a team. And most importantly, we proved that speed doesn't mean cutting corners. This is how professionals build fast. Quote, "The best code is code that ships. Perfect is the enemy of done. Focus on building, iterating, and deploying. Speed is a feature. Every successful developer ever." Now it's your turn. Take this exact process and build something you're passionate about. A portfolio site, a blog, a tool you've always wanted. The framework is here: planning, building, deploying. Drop a comment with what you're going to build. And if you built along with me today, I want to see screenshots. Share them below. Next video, we're building a Netflix clone in 2 hours. You don't want to miss that. Hit subscribe and I'll see you in the next one. Keep coding, keep creating, keep forging.